Okay, let's formally kind of put some ideas together for right hand, left hand midpoint trapezoidal sums. Okay. Yesterday we just focused on right hand. Okay, and this was the idea that we used. We took the width times the sum of the heights. Yep. We'll show you the sigma tomorrow. Okay. All right. So right hand sum then, if I kind of just draw a small picture here where I've got a function and we're going to bound it from A to B, and we're going to divide it up into n rectangles, okay? The first thing that we want to talk about, and this is assuming that, you know, that formula really only works if they're all the same width, okay? If they're not the same width, which really only happens in the AP test, then you got to do something different. We'll talk about that when we practice for the AP test. But for right now, in order to get the width, how would you find the width here? What's the B minus A? So width is equal to B minus A. And if you're going to divide it up into n rectangles, the width of each rectangle would be B minus A over n, correct? So the right-hand sum would then be that B minus A over n, okay, times then the sum of the heights. Now here's what's interesting, okay? All right? We're going to go over a certain number of widths. So like this would be A plus W sub 1, right? This would be A plus 1 width. So A plus 1 width. And then that would be A plus 2 widths, so on and so forth, correct? Yeah, all the way up until this last one, B, would be A plus n widths, right? So for this very first interval, where would you evaluate the height? Would you evaluate the height, if you're doing right hand, would you evaluate A or A plus W? Yeah, so you do F of A plus W. And then where would you evaluate the second height? F of A plus 2W. Very good. Plus dot, dot, dot. And then what would be the last one? Yep. F of A plus NW. And that would give us all of the heights. We just take those numbers and we plug them in to get the height. We all good? Yeah. Now let's do left hand, because left hand will be just slightly different. L sub n is equal to, we do that B minus A over n, that's the width. And then what's going to be different here? What? Like, are we going to start at A or A plus W? We'll start at A. But then we do have A plus W, right? F of A plus W was F of A plus 2W, so on and so forth. What's going to be the last one? Do we do it at, it'd be n minus 1, right? It'd be 1 less. So A plus n minus 1 times W. Yep. So we lose the 1 at the end for left hand, but we pick up the 1 at the beginning, right? Yeah, we lose the 1 at the end, but we pick up the 1 at the beginning. And that's the real important idea you guys have to think about. Trapezoidal sum, what do we do the left hand and the right hand to get trapezoidal? Yeah, we average them. So R sub n plus L sub n, we just divide by 2. That's super nice right there. Yeah. Then we got this midpoint one. So midpoint's going to be a new one for us today. So midpoint, I've got that B minus A over n as my width. Now, look at this. If I'm doing the midpoint, that means I go to the middle of between A and A plus W. How would I get to the middle of A and A plus W. I'd add them up and divide it by 2, right? Yeah, so I do A, so F of A plus W divided by 2, right? And then plus dot, 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 dot. We continue all the way down. F of, what would my last one be? NW, and then the one before it was A plus N minus 1 times W, all divided by 2. So you have to average them to get that middle. Okay? That's how we get it. Now, I'm just writing kind of generic notes up here. I don't want to get too deep into this. I want to get to the actual kind of application we're going to use. Are you ready? NW. Okay, let's do this. Use the following table to determine the approximate area bounded beneath the function over the interval -2 to 6. So what I'm going to do first, I'm going to come up with the width of each rectangle. What's the width of the entire interval? Yep, I do 6 minus -2, so B minus A divided by N. And I'm doing 4 rectangles. So I get 8 divided by 4 is 2. So the width of each rectangle is going to be 2. So if the width of each rectangle is 2, I go from -2 to 0, 0 to 2, 2 to 4, 4 to 6. So for the right hand, where will I evaluate the first height? And I get 1. Plus, where do I evaluate the second height? And I get third height at, and I get, and the final height, I evaluate at 6, and I get 6. So I add those up. I get 8 and 8 is 16, plus 6 is 22, times 2 is 44. And what we won't use any label unless they indicate. And AP does the same thing. If they don't give you a label, then don't worry about it. Okay, left hand's gonna be the same thing, except, okay, exactly. So Carter sees that's gonna be the same thing, but I get rid of the end, but I pick up the beginning, right? Very good. So we have 5 plus 1 plus 7 plus 8. Very good, 42. Trapezoidal, I'm going to do that before the midpoint. Trapezoidal, it's just the average, right? L4 plus R4 divided by 2, so 42 plus 44. And I get 43. So then I got to do the midpoint. So I got 2 times, what's the middle of -2 and 0? -1. And so I use 10. What's the middle of 0 and 2? 1, so I use 5. And then the middle of 2 and 4 is 3, so I use, and then 5. And I get, let's see, 20, 36, 72. Now, when I use table values like this, I just kind of make them up real quickly, so you notice that these don't match up very well, do they? But that's just kind of how it happens. Okay. We good? Yep, that's it. So that's a table one. Let's go to an equation one. We'll start setting it up. So we have 3 more examples to do. Okay. It says area bounded beneath -x squared plus 16, the x-axis and the y-axis in quadrant 1. So I know I'm going to get some space over here, so I'm going to use this right now. What does that graph look like? Yeah, what y value is it going to go through? And what are the x values it's going to go through? Positive, -4, very good. And it says it just wants the x-axis, the y-axis, in the first quadrant. So what's my interval going to be? Yeah, it's going to be from 0 to 4. And if I divide it up into 5 rectangles, what's the width going to be? Yep, 4/5 or 0.8. So this is where some people get confused. They start to get fractions. We'll just go over one width. If I go over one width from 0, I get to 4/5. And then 8/5, 12/5, 16/5, and then 20/5, which is 4, right? So I'm going to do f of, if I do the right-hand sum, what do I plug in first? 4/5, and then 8/5, 12/5, 16/5, and 4. Yeah. So I go into y equals, and I type in that negative x squared plus 16 and I already typed in the values, and that's what I get. So I have 15.36 plus 13.44 plus 10.24 plus 5.76. I'm going to multiply all that by 4/5. Are we all clear? Okay, let's add it up then quick. I know some of you guys are doing on your calculator as well, and others are just kind of keeping up with me. That's fine. Just want to try to punch through this quick so we can get it before lunch. Yeah, what was the last one? It was 0. So I get that, and then I multiply by 4, divide by 5, and I get 35.84. Now, that looked like it took a long time. And the left hand, we're going to actually be able to do really quickly. We'll talk about that right when we get back, as well as the trapezoidal. Okay. Exactly. Well, no, you'll drop off 0. We had 0 on the end. And then you'll pick, no, you got to pick up the first one. Okay, here we go. All right, so we got this one. So the question is, what's going to change for the left hand? I still have 4/5 times. I start with, okay, so I start with f of 0, right? Plus dot, 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 and I end with f of 16/5, right? So I can actually go to my calculator, and if I turn it on, I can see that it's summed to 44.8, didn't it? So you take that 44.8, I subtract off the 0 because that was the last number, right? And I pick up, as you said, 16, and I got to multiply that by 4/5. I get 48.64. How would I do the trapezoidal? I multiply by 4/5. So, but this is f of 16/5. 16 is f of 0, right? So f of 0 is 16. You plug in 0, you get 16. You see that now? Okay, so 48.64 plus 35.84. We're going to divide that by 2. Plus 35.84. And we divide by 2, and we get 42.24. Now I'm not going to write, we're not going to do the entire midpoint, but we're going to talk real quick about how you would evaluate it. I still have that 4/5 times f of, I got to go to the middle of 0 and 4/5. What would you use? 2/5. And if I did the middle of 4/5 and 8/5, I would do, yep, f of 6/5. What would be the last one I would do? This is 20/5. So 18/5. Very good. And that's what you would have to do. We all good there? Okay, so we got two more examples. This one, we're going to do a graph. Okay, so we're going to look at the picture we have here. And it says, use the following graph to evaluate the sums over the intervals 0 to 120. And so I got from 0 to 120, and I'm going to do 4 rectangles. So what's going to be the width of each one? 30. So R sub 4, where would I start by evaluating the first one? And I get 40 plus 80 plus 20 plus 100. The 120 is 240 times 3 is 7,200. Okay. What's going to change about L4? Good. So, Andrew sees it. I gain a 0. I keep the 40. I keep the 80. I keep the 20, but I lose the 100. So I get a 0, I keep the 40, I keep the 80, I keep the 20, I lose the 100. 3 times 100, or 30 times 140 is going to be 4,200. How would we do trapezoidal? So 7,200 plus 4,200 divided by 2, 5,700. How accurate do you think the trapezoidal sum is? Look at it. Yeah, in this situation, it is exact. It is exact. Okay, let's do the midpoint and see how that compares. But the trapezoidal is exact. You can see geometrically how that works out. So, okay. So I do the last one here. Where do I evaluate this height for the midpoint? So 15, 45. Yeah. The midpoint? Well, let's watch. Because it has to do with the geometrical representation, which is why we're doing all the kind of different examples. If you look, this would be the height right here, 15, right? So then as I draw the rectangle, is that an overestimation or an under or exact? It looks like it's over here, but it's under here. It looks like those cancel out, don't they? So the midpoint is actually very similar to the trapezoidal. In this situation, it's going to be the same. But we would have 30 times. The first one is 20. And the second one, you guys said to do it at 45. What's the height at 45? So I'll do 60. And then at 75, it looks like I have a height of, yeah, I'm going to say 50 there. And then at 105, it looks like I have a height of 60. And so I get 80. So 190 times 30 is 5,700. And so it does work out. So you can see that the midpoint is a very good approximation because you have these overestimations and you then have these underestimations that takes care of. So we've got our one last piece here, and you're going to have your calculator for it. And this can no, it doesn't take up that much space. I just the next lesson that we do, we don't have room to kind of continue on another page. This doesn't really have to be that bad, but it will kind of depend on how well you use your calculator. Okay, all right. If you don't have your calculator, then you just kind of need to follow along. Right, so I'm going to picture the graph here. What does the graph look like? It's a wave. What's the period? 2 pi. What's the amplitude? 1. Now, here's something that's interesting. We talked yesterday about area, that it could be positive and it could be negative. Area in calculus can be negative when it sits below the x-axis. You might think that has no application, but it does. In economics, area above would be considered, say, profit. Area below would be considered, say, debt. Okay? So there is applications. We move forward to this without a doubt. Now, if I looked at the area from 0 all the way to 2 pi, what do you think I would get? From 0 to 2 pi. Zero. Why, Dana? Yeah, one's positive, one's negative. They'll cancel each other out. Okay? No. We're going from 0 to pi. So we're just looking for this area right here. Okay? All right. Now Jake's guessing pi. He's incorrect, but let's see how close he is. Okay? Now what we want to think about is we're doing how many rectangles? Yeah, so we're going to start with r sub 100. Now this looks ridiculous, but it's not that bad, okay? Because you're going to use your calculator to help you out. First of all, what is the width? Of the entire interval is pi over 100. That's going to be the width of each rectangle, right? Okay, so this spot here would be 1 pi over 100, and then we would have 2 pi over 100, and pi is 100 pi over 100, and what's the one right before it then? 99 pi over 100. Is everybody okay with that? Very good. So here is what we need to type into our calculator, okay? In order to calculate all these, because we have the width is pi over 100. And what we need to do right now is we need to come up with the sum of the heights. And we can use our calculator for this. We type in this is the formula. We take the width and we multiply it by sum sequence y1 comma x comma beginning comma end comma width parentheses. Now you're going to have to do this on the test. So you're going to need to make sure that you know how to type this in. And it's not that bad. Beginning. So I'm doing right hand of 100 times the sum of the sequence of y1 comma x comma. Where will you begin identifying the height for the right hand sum? So you're going to begin at pi over 100. Where do you end evaluating the height? At pi. And what is the width of each rectangle? Wow, okay. That was aggressive. Okay, does everybody have that piece written down? Okay, we'll wait for you. then the key is to get that typed in properly into our calculator. Sequence. Is everybody ready? So we can do the calculator piece together and get it, okay? All right, we go into y equals, and do you know what you put into y equals? Anybody want to guess? Sine of x. And please make sure you're working in radians, not degrees. I would have ended up with a big issue there. Okay, so I got sine of x in there, and now I type in exactly what I have here, which is pi over 100 times, we do sum. And here's how you get to sum. Second catalog. Catalog is 0. I'm in the A's. How do you think I get to S? I press S. Or you can press T and back up, and sum's right there. Are you ready for me to move on to the next part? Okay, now what do I grab? So I do the same thing, catalog, and I'll go S for sum, or for sequence. I'm going to scroll down, and it looks like I do this sequence one, the one with the parentheses, smaller case sequence. Enter. SEQ parenthesis. Now I need y1. This is the last confusing part. That's a variable. We need to go into your variables, vars. It is a y variable. It is a function variable. It is y1. If you don't want to put in y1, you could just put in sine x, and that would be fine as well. Okay. Comma. Comma is right above the 7. I need to now tell the sequence that my variable is x. Comma. I need to tell it where to start evaluating the heights. Pi divided by 100. Comma. I need to tell it when to stop evaluating the heights. And I need to tell it between pi over 100 and pi, how often does it stop to evaluate a new height? Well, whatever the width is, which is pi divided by 100. And if I do that, instead of us calculating this 100 times, we can simply do that, press enter, and it's going to have to think for a while because this is a really complicated calculation. And we'll go to 4 decimal points. We'll go to 5. We got 1.99984, we'll say. Now, before you freak out, the hard work is done. The rest is quite easy. Watch. Does the width change? So it's pi over 100. I still do sum. I still do sequence. I still do y sub 1. I still do x. But where do I start? At 0. Where do I end? 99 pi over 100. And what's my width? Now, I know you're worried about typing this all back in. Don't. Watch. Shortcut. You ready? Second entry. Boom. It's all there. Entry will bring up whatever you use. Back, so I can just back up and go to this pi over 100. I'll put 0, comma, 99 pi over 100, comma, pi over 100. That wasn't bad at all, was it? That'll do the left hand. $1.99885. I'll do the midpoint. Uh-oh, we got to do some thinking here. What's halfway between pi over 100 and 0? Pi over 200. What's halfway between 99 pi over 100 and 100 pi over 100? 199 pi over 200. Any questions how I got those? You will take the two and average them. 99 pi over 100 plus 100 pi over 100 and divide it by 2. That will give you 199 pi over 100 divided by 2 over 1, and so you get over 200. Or you could think about it, I'm just going to back off whatever that width is right off of there. Okay. All right, so let's make this quick. I just go into here, and I do second entry, and I just change it. Instead of 0, I've got pi divided by 200, comma, 199 pi divided by 200, comma, pi divided by 2, or what's my width? Pi over 100. That's a mistake that people make, and I almost made it. People do it on tests all the time. And I let it think for a while. I get 1.99959. So it's 5 decimal places. How would I do trapezoidal of 100? Yeah, 1.99984 plus 1.99885, and we divide it by 2. 1.99984 plus 1.99885, and I divide by 2, and I get 1.99935. If I wanted to see the exact value, what do I press? 7. And you would go from, what's my lower limit? My upper limit is pi. And Jake said pi. Turns out it's dos. Spanish for 2. Good job, folks.